Hello, today we are going to look at guarding in and around buildings to prevent people from falling. This is something that can cause misunderstandings and differences in expectations between clients, contractors and perhaps architects on the one hand and building inspectors on the other. The legal requirement that needs to be fulfilled is to meet requirement K2 of the building regulations. This tells us that stairs, ramps, floors, balconies and roofs where people can access them, along with light wells, basements or other sunken parts of buildings, should be provided with barriers to prevent people in or about the building from falling. On accessible roofs, this would also include around roof lights. On the face of it, this is quite easy to understand. If a person could fall off of or from a building, they need a barrier to protect them so they can't fall. The last line of requirement K2 that refers to in or about the building can be subject to some interpretation. I think we can all appreciate what in a building means, but about a building, that might require some discussion with your building control provider. There may be an expectation of compliance for some external features around the building. This might include a patio, external seating area or deck area with a drop-off around the perimeter, for instance. Routes from car parking or the edge of a site to the main entrance will usually need to comply. As ever, if in doubt, seek some clear dialogue with your building control provider as early as possible, so that expectations are clear. Guarding should always be appropriate for the circumstances, and approved document K advises that for dwellings, guarding should be provided wherever there is a change in level of more than 600 millimeters. In non-dwellings, guarding should be provided to prevent falling more than the height of 2 staircase risers, or 380 millimeters if the change in level is not part of a stair. Requirement K2 does not need to be met on features such as loading bays, where a barrier would interfere with normal working. Diagram 3.1 of approved document K gives typical heights for guarding in different locations. So, in a single family dwelling, for instance, guarding to staircases, landings, ramps and internal floors should be at least 900 millimeters high. If that house has an external balcony or accessible roof, then guarding in these areas should be at least 1100 millimeters high. Diagram 3.1 shows the expectations for different types of building, as well as different locations in and around each building type. If a building may be used by children under the age of 5, which would include all residential dwellings, guarding should not be climbable, so avoid horizontal rails. And a 100 millimeter diameter sphere should not be able to pass through any opening to prevent children from becoming stuck. In diagram 3.1, the guarding height recommendations for glazing, either at opening windows or changes of level, are noticeably lower at 800 millimeters. One of the British standards referenced within approved document K relating to more detailed barrier design is BS 6180, titled Barriers in and About Buildings Code of Practice. This is quite a readable British standard, much of which repeats the guidance in approved document K. But it goes further and in Table 2 gives specific guidance on the applicable loadings for barrier design. Basically, different types of buildings need barriers that resist different loadings. This is quite sensible, and although the type of buildings described in Table 2 do not correlate exactly with the building types described in Diagram 3, it is usually easy to identify the relevant applicable loads. Loading requirements are split into 3 categories. A horizontal, uniformly distributed line load, which should be applied to the top of the guarding, typically the handrail. A uniformly distributed load applied to the infill, this is the area between the floor and the handrail. And lastly, a point load, for instance, sudden impact. This is also applied to the infill. In typical domestic situations, the loading requirements are low and can usually be satisfied by over-the-counter timber products or perhaps more bespoke metal designs made by a fabricator or blacksmith. And it is unlikely your building control provider will ask for structural calculation to prove compliance. However, as we can see from other building types in Table 2, the loading requirements can increase by some quite significant multiples. Take a bar or nightclub for instance. The line load would be 3 kilonewtons per metre, whereas in a domestic house setting it would only be 0.36 kilonewtons per metre. Accordingly, in some building types it is quite normal for your building control provider to expect some structural calculations to show that the barrier design chosen meets the minimum requirements of Table 2 and demonstrates compliance with requirement K2. As loading requirements increase, we would always advise that guarding design is done in conjunction with either a specialist designer or installer or structural engineer. A design feature that we see quite a lot of across all building types is the use of glazing as guarding. This can be freestanding guarding, perhaps fixed only at the bottom edge, fully framed around all sides, or even full height glazed windows in walls. These must still meet requirement K2 and in terms of specific loadings should still meet all the relevant requirements in Table 2 of BS 6180. For glass guarding, we would always advise that a specialist is used. Clause 5.3 of BS 6180 tells us that the barrier adopted should be designed so as to minimise the risk of persons falling, rolling, sliding or slipping through gaps in the barrier. In terms of glazing, it is clear. Either it should not break, or if it does break, it should still not allow penetration by the person causing the impact. Glazing in guarding can be defined in two basic types, monolithic or laminated. Monolithic is a single sheet of toughened glass, and whilst this may satisfy the loading requirements in Table 2 of BS 6180, if it ever does get damaged, then it is usually imperative that additional temporary guarding is provided until replacement occurs. Laminated glass containing 2 or more layers can also be used. This may provide more containment if it is damaged. CE marked or kite marked glazing products indicate that a level of performance is attainable, but not necessarily that the guarding system as a whole is compliant. The mounting of toughened glass guarding in frames requires particular attention to avoid, for instance, direct metal to glass contact, as this can cause toughened glass to easily crack and fail. A consideration in some taller buildings over 18 metres high with glazed barriers is fire safety, and this can impact on the use of laminated glass products. Further to the Grenfell fire tragedy, it has been identified since November 2018 that the polymer interlayers in laminated glass products in use at that time did not comply with the requirement that building envelopes achieve a non-combustible rating. It was considered that the polymer interlayer in high heat fire conditions could form flammable liquid droplets, which could then fall onto other balconies or floors below and spread the fire. This meant that laminated glass could not be used to provide guarding in taller buildings. However, I understand that some manufacturers are now able to produce compliant glazing with suitable non-combustible interlayers. Always check with both your supplier and your building control provider in this case. One further area of consideration is Approved Document O, which deals with overheating. This was introduced in 2022 and provides some additional requirements where windows are relied upon to provide natural ventilation. The relevant guidance starts at paragraph 3.8 on page 13 and also diagram 3.1. Basically, windows that are provided as part of a natural ventilation strategy must have a minimum height of 1100 mm if they open by more than 100 mm and the change in floor level between the inside and outside is more than 600 mm. This could lead to the incongruous situation where two windows are alongside one another in an external wall, but only one is needed as part of the ventilation strategy, and this needs a guarding height of at least 1100mm, whereas the other window, not part of the ventilation strategy, needs a guarding height of only 800mm, and both would be compliant with the relevant approved documents. If you have any questions, please get in touch with us via the number that's on the screen now. And if you found this video helpful, give it a like and share it with someone else. Thank you for watching.